Hi, my name's Evan Talan, and I'm a mechanical engineering student at Oregon State University. Not only am I an engineer, but I'm also a runner. I see an issue with the current running shoe market that only few companies have addressed. Shoelaces are holding many people who can't tie them back. Rather than redesigning just one shoe, I thought it would make sense to design a system that can be installed by the shoe store that could fit to almost any shoe. This is the product. It consists of a plastic wishbone to hold the upper open for easy entry, and a pull-tight lacing system for easy closure. The wishbone was manufactured using moldable, flexible plastic that melts at a low temperature. Following a 3D model as an ideal shape, the plastic was placed in hot water and molded into the shape. The shape of the wishbone is key to the design, so getting this right takes a lot of checking with the shoe. This design allows for flexibility so that once tightened, the wishbone folds in on top of the user's foot. If manufactured for mass production, I would suggest using injection molding for this. This would make high volume production much easier and much cheaper, and allow the company to produce many different sizes for many different users. Placing the wishbone underneath the insole ensures a comfortable fit. Here I used a punch to make a hole for the laces to string through once the wishbone is inserted. The last bit of this wishbone was cleaned up using a Dremel. This allowed for some of the rough edges to be taken off and the profile to be slimmed down to make a more comfortable fit. This was actually the source for the biggest issue with this project that I had to overcome. Getting the right profile so that it fits snugly with the foot and so it was comfortable was the hardest part of this thing. The lacing system was intended to be a retrofit for the existing laces, replacing this with a pull-tight, no-tie system that integrated with the wishbone. The lacing system was not as much manufactured, but the manufacturing processes were used to integrate it with the shoe. The laces were strung through and lock clamp put into place. Lacing through the wishbone provides a better fit. The nylon strap was stitched to the upper of the shoe so that once tightened, the laces have somewhere to stay so they don't flop around. In a mass production process, this nylon strap would already be cut to size. Once in the shoe store, I would suggest this be attached to the upper using a sewing machine without the lacing system on the shoe yet. Here I am finishing some of the stitching for the nylon strap onto the upper. Once it's stitched on, I use some industrial adhesive to make sure that the stitches don't come loose and that the nylon strap stays fixed in its position. Once put together, this system provides the user with a much easier experience when putting on shoes. This can be manufactured in many sizes and sold to shoe stores where they would just need to insert the wishbone, stitch a glue on the strap, and relace the shoe.